Start. Okay, today we'll see the subject of abstract class. This was a topic today. So what is abstract class? See, abstract class is one more data type in Java. Okay, so Java is very rich in data types. You have seen how rich is data types. How rich is in Java in data types? You are seeing now. Okay, so one more data type which we are going to start studying now is abstract class. So abstract class is also what now? So from the interview point of view, tell these 2 points. It's very important. Do not tell your old age-old definitions. A class which is just declared as abstract is abstract class. All that is stupid answer. Better you give these definitions. Abstract class is a what? User defined data type in Java. Used for what? Implementing OOPS. First thing, used for implementing OOPS. See, OOPS is a concept. In OOPS, you know what you are having now? Encapsulation, inheritance, polymorphism, abstraction is there. If you want to do all that for, you can use any data type here. You can use class also. You can use subclass also. You can use abstract class also. Or you can use interface also. Now, Java, why is Java giving 4 data types to implement OOPS? That story we'll see next. Understood? But this is also one more data type in Java which is used for implementing OOPS. First point. Second point, what you have to tell in interview, what is an abstract class, why do you use it and all. One more thing is you have to tell abstract class is used for doing what? It's used for doing partial implementations. Is used for doing, we'll see what is partial implementation later, for doing partial implementation. Partial. Okay, and you have to continue your partial implementation and see, this is very important point. Setting standards. Setting standards for subclasses to complete implementation. To complete implementation. We'll see the second point later, don't worry. But these are the 2 important things you have to tell about an abstract class. These are the 2 most important things you have to tell about an abstract class. So what is an abstract class, why it is used and all, we'll be seeing it. But from abstract interview point of view, these are very, very important points. Got it now? From interview point of view. Okay, let's start seeing now. One by one all the topics. Are you clear these 2 points now? But I know you need the explanation for this. Examples are only the answer for these 2. Examples are only the answer for any point here. Theoretically, if I give notes like this, you are very much used to all these kind of notes. You have seen plenty of definitions, plenty of notes. All this you know, but all this has to be proved only with examples. I'll give you examples in next abstract class also. Okay, fine then. Next. See, before we proceed ahead, again, there are 2 words you have to understand. What is abstraction and what is abstract class? These 2 words also you have to understand before we proceed ahead. Okay. See, abstraction is a OOPS concept. Abstraction is a OOPS concept. Abstract class is a data type in Java. There is a huge difference between both of them. Understood? See, abstraction is a OOPS concept. Okay, if you see abstraction, what is it? It is a OOPS feature or concept. It is one of the OOPS concept. Abstraction is one of the OOPS concept. But here, abstract class is what? Data type. Other side, if you say abstract class is a data type. If you want to see the difference here, it is a data type. I told you, used for implementing OOP. So data type used for implementing OOP means using an abstract class. Check this out carefully now. Using an abstract class, you can implement what? Encapsulation, all the 4. You can do polymorphism, you can do inheritance, and you can do abstraction. So abstract class is used for implementing what? The OOPS concept. Like I have shown you, a class can be used for implementing OOPS, a subclass can be used for implementing OOPS, An abstract class also likewise can be used for implementing OOPs. We are studying OOPs in all the data types. Generally you learn OOPs theoretically and forget off. But actually you have to learn OOPs in all the data types. How OOPs is being supported in all these 4 data types. So we learn the support of how these data types are giving support to implement OOPs. We'll learn that. Then later on we have to discuss which data type is used when, under what scenario for implementing OOPs. There are scenarios. So in one scenario you'll be using one data type to implement OOP. It's not a standard thing like you use class for implementing OOP or use subclass for implementing OOP. There are some scenarios. I'll give scenarios and make you understand. In some scenarios class will suit best for what? Implementing OOPs. In some scenarios subclass will suit best for implementing OOPs. In some scenarios abstract class will suit best for implementing OOPs. So depending on your scenario you have to pick the data type and implement OOPs now. So implementing OOPs is not important, picking the data type is important. Generally when everybody asks you to write the code, you have a tendency, what is that? Directly write class A, start writing code. That is rubbish. You should never write a code like that. You should first think which data type to choose. Whether you will choose a class, whether you will choose a subclass, whether you will choose an abstract class, and then write the code. Are you clear with this? So that's how coding will start off. Anyway, after you complete the data types, then you can choose. Before knowing the data types only, how will you choose? Yes or no? So once I complete all the data types, then you can decide when I'll go for a class, when I'll go for a subclass, when I'll go for abstract class, and one more is there, when I'll go for an interface. That's how the decision will be taken. So abstraction is a OOPs concept now. See, in OOPs, remember how they have done in Java, what they have done. In OOPs, there are 4 features. These 4 features of OOPs are supported only for 2 things, reusing and avoiding complexity. OOPs is giving you these 4 features only for 2 main reasons. Okay, see, encapsulation is there. What is encapsulation? You know the story. You'll tell binding the data, hiding the data, and making the functions or behavior work upon the properties. You have some definitions. Leave all the definitions. What is encapsulation? Leave the definition. Why do you do encapsulation? Reusing and avoiding complexity. Main reason why you are doing encapsulation is reusing and avoiding complexity. Why do you do abstraction? Means reusing and avoiding complexity. See, I'll write the code in a class. Okay, once I write the code in a class, if I want to use it, what will I do? I'll create an object, means I'll bring the code into existence and start using it. How it is working, we don't know. That itself is what? Abstraction. But how did you achieve abstraction? With the help of which data type? Class data type. Similarly, abstraction can be achieved with the help of subclass data type also. You write on subclass, create an object. You can work with that object now. Same way what happens here also, you can achieve abstraction with the help of abstract class. But why do you do abstraction? Reusing and avoiding complexity. Same way, inheritance. What is inheritance? You know, it's the process of inheriting the functionality of one class into another class. All that story you know. But why do you do it? Reusing and avoiding complexity. Answer is same for all. Okay. So, then last one is polymorphism. Again, why do you do polymorphism? Reusing and avoiding complexity. So to implement OOP, to implement OOP means all this is done for only one main reason or 2 main reasons. What is that? Why do you do encapsulation? Reusing and avoiding complexity. Why do you do in abstraction? Reusing and avoiding complexity. Reusing and avoiding complexity. Reusing and avoiding complexity. So OOPs means the support of OOPs was given to by many languages like C++, ADA, Smalltalk, all that. It was they tried to give the same support. Same support they are trying to give. Okay, Java is also trying to do the same, nothing different here. Okay, but to implement these OOPs, Java is giving 4 data types. Remember that. To implement OOPs, Java is giving you 4 data types. Okay, one of the data type which we have seen is class. We have already seen. Class can do all the 4, yes or no? Okay, second one, subclass can also do all the 4, yes or no? Third one, abstract class also can do all the 4. Yes, we'll see that now. And an interface also can do all the 4. But that's the thing. I told you when to use class for implementing OOPs, scenarios will come, that you will understand. But in C++ also I got the same support for what? OOPs. But there how many data types they are giving you? Only 3. C++ is giving only 3 data types for implementing OOPs. Yes or no? Class, subclass, abstract class. Means it is very poor. It's very poor. So Java is rich. Java is giving you very rich support for what? Implementing OOPs. But at the same time it is user friendly. That is more important here. The most important part of Java is it is giving the support also as well as it is user friendly. Smalltalk, ADA also they try to do the same thing. but they have their own data types. They use their own data types to implement hoops. But Java's data types are user friendly also. You know how easy it is to work with the class now? What will you do? You know how to work with the class. How do you work? Write a class, create an object, work with the members of the object. How? With the help of dot operator. No pointer, int, headache and all here. Reference variable. Use the reference variable to work with your object. Very simple. But the same in C. C is also giving you which one user defined data types. The user defined data types of C, you notice, they can only store data. They can only store data, but your user defined data types of C cannot implement hoops. Can they implement hoops? So no doubt they are weak, but more complicated to use also. C has got user defined data types, but they are complicated to use. They are very simple, means they do not use rich support. They are very simple data types. C structure, enum, union and all, they are very simple data types, simple data types. Okay, and they can store. Why did I call them as simple data types? Because they can only be used to store value, nothing more than that. Okay, but they can be only used to store value, but using them becomes very difficult because you have to work with what? Pointers. Okay, Java's this is with C. Okay, but in Java they are rich. Why they are rich? They can store data. They can store data. Plus you can implement hoops, and at the same time they are user friendly. So you can see how rich it is now. So Java's user defined data, why they are so rich? Java user defined data types, all the 4, why they are rich? So if you wish to store the data, you can store data. Yes, Java user defined data type are very rich because of the following reasons. One is they can store data. Second, they can implement hoops. Yes or no? Okay, then user friendly. What do you mean by user friendly? Simply you will create object. You have a reference variable, you can work with it now. In C, to work with your user defined data, what to use? Pointer. If you want to send it as an argument and all, what will you use? Pointer concept comes. Here if you want to send it as an argument, what will you use? Reference variable. So it is user friendly to work. And on top of that, what it is? It is portable. The data type what you design, your class, your subclass, it can run in any operating system of the world. You can see how rich it is now. Understood? C data types are what? They can only store data. They are simple but complicated to use. So like that you have to compare the data type. Understood? Like that you have to go on comparing the data types. So then means as we progress only you'll understand the richness of the language. As we progress only you'll understand. Now you can understand this much. As the class progresses you'll understand still how rich it is. Now more I can't tell, but just understand how good support you are getting from the Java language. Are you clear with this? This is why Java is having very rich data types, user defined. Primitives are anyway powerful, you know that. How rich are primitives you already studied. Okay, they are type checked and they give you accuracy. All that we have discussed. Primitives are also very rich. At the same time user defined data types are also very rich. You know, byte, chart, int and all, no? Primitives are also very rich. At the same time user defined data type is also very rich. Shall I clear all this now? Okay, then shall I clear? So once you write a code in Java, it takes you to a very high level of reusability. So next thing is, yes sir, now little we might be confused. Okay, what is the confusion you might have? Like, okay, so many data types are there. Which one to use when? Java is giving clear instructions. If this is your scenario, use it. If this is your scenario, use it. Okay, it does not create any confusion. Only you get confused because you don't study them properly. You study it properly, automatically you'll understand which data type to use when. Understood? So let's see now. You want to code something. If I give you some task, code something. Okay, so you want code now. You want to code. Okay, take the scenario first. General I'm talking. If code exists, there will be two scenarios. If code exists, code does not exist. Yes or no? There will be only two options. Means I ask you to code something. Sometimes code might be there. Sometimes code might not be there. If code exists, what will you do? Simple. Create object. Use it. Means bring the code into existence. That's what Java says. You create the object and use the code. Creating object only is nothing but what? bringing the code into existence. That's it. A code does not exist. One second. Code exists. Yeah, if code exists, you can, one second, create object and use it. This is your option. Code exists, you want to modify, then you write subclass. So code exists, but you want to modify. If code exists, you are happy with the code. Means, one second. If code exists, if you are satisfied, with the code, what will you do? Create object, use it. Understand? And use it. Okay. Code is existing. Want to modify code? Then what will you use? Use subclass data type. Understood when to use subclass data type? Now modification of code means, you know, adding members, changing, overriding. You know what is modification? Huh? Do that. It's correct only, but just I'll read it right properly. See, scenarios you want to code. If you want to code, yes. If code exists, you will do this. Code does not exist. If this is the case, okay, here you'll be having two options. Still it will continue. I'll write it today, but later on I'll be explaining you this. Code does not exist. One option is you want to write completely new code, fully new code. Means you want to write concrete new implementation, we say. New code, completely new code if you want to write. So that time Java says use class data type. Understood when to use class data type? See, use subclass data type. Very clear it is. Then you want to do partial implementation. So right now you will not understand what is partial implementation. I'll be completing today, then you'll understand what is partial implementation. Okay, that time Java says use abstract class data type. Understood? Sometimes no implementation. You do not want to do any implementation. It is no implementation. I don't have space here, just understand. I am writing no implementation. Understood? No implementation is you don't want to write any logic. So that time you will use which data type? Use interface data type. Anyway, interface is the next data type, we'll see that time. Like this, Java is classifying everything neatly. There is no confusion here. This is your problem, use this data type. This is the problem, use this data type. Understood? Very neatly it classifies. So in interview also you have to talk in the same way. What is difference between class, subclass, abstract class, interface? Okay, it should be told in a very clear way. Anyway, I'll go to this level of explanation after I complete interface. Okay, so see, learning the data type. You have to learn the data types here, user-defined data types. See, I'm teaching you these user-defined data types from 3 points of view. One, from language point of view. Means, you can imagine, if you have experience only, you can cover like this. Understood? One, I'm teaching you data types from language point of view. I told you, we are learning 3D Java. Yes or no? So one we are learning, right now we are learning it from what? Language point of view. Second, we'll be learning it from what? How it is used in technology. Technology means what? Ready-made libraries. In libraries, they'll be giving you so much of code, but all the code where they'll give? Either in a class, subclass, abstract class, or interface. Like some technologies, some example like Servlet, JSP, okay, or you might have known something like JDBC. So they are giving you all these are libraries. End of the day, in that library, what are you seeing? You got class there, subclass there, abstract class there, interface there. Apart from that, what is there? I told you, once you write your data type, you can reuse it in any operating system of the world. So that's why what will Sun do? They will only give most of the libraries. So one is we are learning it from language point of view. What is class, what is subclass, what is abstract class, and all that. Then I'll make you understand how they have used these data types to build the technologies. I'll be making you to understand how these data types have been used to build the technologies. Then third, we have to write application now. After learning all this, what is your intention? You want to write an application. That to which application? Not small application now. You want to write what? Web application, distributed application. That is what you want to write. So there, we'll see how to use these data types in writing application. So that is why you should be so perfect in these data types. Very perfect. There you will not have any allowance. There when I am coding, if I use class, you should understand why I am using class. If I use interface, you should know why I am using interface. Okay. And when I am writing a class, subclass, you should know what are the allowed members, what are the not allowed members. Then if I am writing code, that code I will write in which member. Like will I write it in a block, will I write it in a constructor. These questions should not come out there. Understood? So you should be very powerful in these data types. Are you clear? Are you clear with this table now what Java is telling? Okay, so this table can be classified only because we have got 10 years of experience in training, development and all that. We can tell all this. Okay, for a normal person if you ask to explain what is a class, subclass, abstract class, you know how they explain. What they tell? Abstract class is abstract class. Correct? Huh? Subclass is subclass. Class is class. Correct? Huh? That's how you tell. Huh? Or other way what you tell is subclass is a class which extends some class. That's how you tell. What is abstract class? Any class which is declared as abstract is called as abstract class. Those who know I am telling. Those who don't know better will not tell only. Understood? Because you are going to learn everything correctly now. Those who learn, you are half baked. How you learn? Correct now? What is abstract class? A class which is declared as abstract is called as abstract class. You should not tell like that. Abstract class is a user defined data type used for implementing hooks. It is used for doing partial implementation. Now what is interface? Interface is a data type which is used for implementing hooks but does not contain any implementation. Like that you have to tell. Understood? Anyway, interface we'll see next. So are you clear with all this? And this is definitely an interview question. Difference between what? Class, subclass, abstract class and interface. In fact, extensively they question you on difference between abstract class and interface, which is the most confusing difference for any person. So to clear that, you go with 5 years of experience also, or you go with 7 years of experience. Still this is a definite interview question. Difference between what? Abstract class and interface. Difference between abstract class and interface is a sure shot interview question. Understood? Okay. So anyway, we'll discuss more about all this topic. Initially what I'll do is I will start learning how to use a abstract class, write abstract class and use a abstract class. Then I'll come into all this explanation. But this was a brief introduction I gave you about what is a abstract class. Clear? Shall I clear all this? Yeah, so we'll start learning how means abstract class now. So if you want to learn abstract class, what are we learning now? Abstract class means what it is? It is a data type, user defined data type. Correct. Learning now means what? Learning a user defined data type is nothing but what? First you have to learn how to design. Correct? How to design or derive. How to design and derive abstract class means the data type. Is how you write. Like in C structure, if you are studying, what will you learn? How to write structure first. Then you learn how to use structure. Same as Java we studied how to write a class. Then we learned how to use a class. Then we learned how to write a subclass. Then we learned how to use the subclass. Now the same thing we'll see. How to design and derive abstract class means first write it. Then next what we'll be studying is how to use. So both you have to study. How to use abstract class. Understood? So both parallelly we'll be learning. I cannot separate it because I have to write on simple example means on simple abstract class I'll write, I'll use it. Okay. So again more examples. So parallelly I'll be going with both. But my intention will be you have to see any example with these things. What intention means with what concept you have to see now? How I'm deriving you have to see. Understood? Supposing I write a constructor there. How to write a constructor? I'm writing a block. Or you can write a block. Like that you have to think now. Your visualization should change. Simply don't by heart, okay, first line I have written a class, second line I have written block, third line I have written constructor. You have to think and understand it now. Clear? So then, using it also I'll show you how to use an abstract class. Are you clear with this? So your abstract class also can contain all the same members. Till now what you have seen, same members it can contain. Okay. So what are the different members your abstract class can contain? I'll classify it. Same thing, it can contain variables. What variables? Static and instance. Then it can contain constructors. It can contain blocks, static block and instance block. It can contain methods. Okay, static methods and instance methods. All these things you have to study. One extra thing which comes out in an abstract class is something called as abstract method. One extra thing what comes out in one extra member what comes out in an abstract class is called as abstract method. Everything is same. Till now what you have studied is correct. What is there in a class, same members will come into abstract class. But I will again prove it with examples only. Simply theoretically telling is different, putting into example and saying it is different. Okay, but one extra member which comes out in an abstract class is called as abstract method. Now you might have the question, what is an abstract method? Okay, so a method without, see generally how do you write a method? You have written all methods, you have written. All methods where do you write? In a class you write. So fine, but you write a method now. But generally the syntax of the method would be, okay, you'll have a return type. This is one return type you'll have. Then you'll have name of the method. Then you'll have, you'll open brace. Then you'll have parameter list. Understood? Then you'll have something called as body. So this is how a method is written generally. This is the syntax of the method. Okay. So this brace is called as body. Okay. So if your method does not have a body, that method is called as an abstract method. So what are abstract methods? Abstract method is a method which does not have a body. So this is one of the member which will be present in your abstract class. We'll learn one by one how to use it. Understood? A method without a body is called as what? Abstract method. Method without a body or implementation you can say. Without a body or implementation means it will not contain any logic. When body, see you write logic where? Inside this brace only, inside the block only. Understood? So if it is not containing the body, okay, or implementation, method without a body or implementation is called as what? Abstract method. But a method which has the body, see, understand the point. A method which has a body and implementation is called concrete method. It's called concrete method. You are understanding the difference between a concrete method and abstract method? Understood? Now this is a syntax. Now example would be something like this. Int add int x int y. See, this method is not having a body. It will be terminated with semicolon like this. It will not have the body. See, this body will not be there and semicolon will be here. Abstract method means it will have only three things. Return type, name, parameter list. This body part will not be there. This is what is an abstract method. Okay. This one syntax. This is the syntax. This is the example. What is the example? Int, return type. Add, name of the method. What is this? Parameter list. And what is this? Semicolon. So it's not having the body now. So such kind of methods are called as abstract methods. So your abstract class can contain such kind of methods. This is one extra member which will come in a abstract class. One extra member. Understood? All members are correct. So before I use the member, I am introducing the member. What is the extra member which can be written in your abstract class? I am introducing it. Are you clear with this? But by chance, if I remove this brace, if I remove this semicolon and put this, what happens? Concrete method. You understood the difference between abstract method and concrete method now? So I'll put, if I do this, it is abstract method. Clear? If I put the semicolon, it is abstract method, and if I give the body, it will be called as concrete method. So this is one brief intro about abstract method now. Abstract means actually, technique means in English, simple English. The meaning of abstract, in simple English, the meaning of abstract is unclear. Unclear. It's not a clear method. Why it's not a clear method? Because it does not have any logic or implementation. So that's why it's called as unclear. Understood now what is an abstract method? Abstract method means unclear methods. Understood? Concrete method means clear methods. Still more. You can take it like this. Clear methods. Concrete methods means clear methods. Abstract method is unclear method. Now why it is clear and why it is called as unclear? Clear means it's having logic. Unclear means it is not having logic. Clear? This is one brief introduction now. Should I clear everything? Should I clear everything? So we'll go straight away with what now? Example. We'll straight away start seeing the example now. Because how much ever I tell theoretically, end of the day, you have to understand all the concept with the example only. So theory we study many, but examples are required to understand the concepts. So all examples which I am showing you are concept based only. They are not output based. You don't see any example in cluster as output. You should not jump around when you get the output here. Understood? Reason is they are all concept based. Because generally you get an output, what do you say? Yes. Correct? Don't say that here. Because here we don't bother about output. Here we go on to learn concepts. Okay, let's see how do you write one abstract class first. A simple abstract class I'll take and I'll show you. A very simple one I'll take. It starts off simple, but I'll give plenty of examples on this. Okay, so all your doubts will not be clarified in one example. More examples, all your doubts will be answered. So generally, how do you write a class like this? See, this is how you write a class. Void M1 SOP inside M1 or AM1 you can take. One second. I need space. Everything. 1 second. I need space. Class A void M1 SOP inside AM1. You can have one more method also. Void M2 SOP inside AM2. Fine. This is how you write a class. So why do you write a class? You know, to encapsulate, to implement polymorphism, to implement abstraction, to implement inheritance. Means you can use a class for anything. So fine, it is there. So this is how you write a class. You know, you are very good in writing a class, but in this class I have shown you only writing methods. I am not having variables constructed and all that, leave. But I have written a class here. So these kind of methods are actually called as what? Concrete methods. A method which has a body is called as concrete method. So there are two concrete methods here. Are you understanding what is method? I am focusing more on method now. Okay, till now, see, I have covered, till now, I think from past 20-30 days, I am only focusing on how to write method, nothing else. If you have observed, I am teaching you how to write return type. Return type I have focused more, returning primitives, returning user-defined data types, correct. Then I have concentrated on name, means you can have the same name, overloading, overriding. Then I have concentrated on parameter, okay, overloading, overriding. Apart from that, parameter and arguments are strictly type checked. What is your parameter? The same type of argument you have to pass. So continuously from 30-40 days we are going with these three things only. What? Return type, name, parameter, and I give plenty of examples for that. Plenty, not one. But I never discussed about body of method. So we are now come to the fourth part of the method. There are four parts in a method. What are the four parts? Name, return type, parameter, body. Three things we have discussed extensively. What are the three things we have discussed extensively? Name, return type, parameter list. Body we didn't discuss till now. So we are now moving to the body part. So once we complete the body part, now the method will be over. Understood? So anyway, see, these are called as concrete methods. Are you clear with what's a concrete method? Okay. Now, I'll write one abstract method here. I'll write one abstract method. Now you know what is abstract method as I told you? Void M2. You have to put brace. Means without brace. Okay. I'm writing a very simple one. No return type, no parameters there. I'll write later. But if you write like this, you compile it. It gives you an error. You write a simple class like this and compile it. Okay. So it gives you an error telling what? Give the body for the method. or declare the method as abstract. Two options you'll get. Declare the method as abstract or give the body. Means make the method as clear. Clear means what? Give the body. Or tell it, you yourself tell it is unclear. Understood? Either you give the body for the method and make it clear, or Java has provided you one keyword called as abstract. Use this keyword and tell now, yes, it is unclear method. So if you do not want to, means if you want to write concrete methods, write it normally like this. But if you want to write abstract methods, you have to use the keyword called as abstract. I'm introducing a new keyword now. Understood? I'm introducing a new keyword called as abstract. So for writing abstract methods, we use a keyword called as abstract. Sorry, I gave the syntax just now, no? In that syntax, just add abstract keyword there before. I just now gave the syntax now for abstract method and syntax, an example I wrote. Beside that you write what? Abstract. The keyword is mandatory. Okay, fine. So now this is abstract method. Now you try to compile. Again, you get a compilation error. What is the compilation? First compilation error is what? Either make the method as abstract or give the body. That's the first error you get. Now you compile. You have made it as abstract. Again you get one more error. Telling make the class as abstract. Make the class as abstract. So class will become abstract now. Now what do you mean by class becoming abstract? See here, if your class is containing one abstract method, okay, if a class is containing abstract method, means it's containing one unclear method. There's no implementation over it. It's containing an unclear method. So obviously it becomes an unclear class. That's the meaning of it. Abstract class means unclear class. Understood? Because your method is abstract, the class also becomes abstract, unclear. Okay. So are you clear with this? So now your normal class you have studied till now. Till now we studied the normal class now. The normal class cannot contain what? Abstract methods. It's only abstract class which can contain what? Abstract methods. Remember that. Till now we have studied classes. Class data type we studied now, subclass data type. Okay. So this class data type, they cannot contain what? Abstract method. Only abstract class can contain clear this. So it is ready now. Your data type is ready. Understood? So this is how you define or derive. Both are same. Define or derive an abstract class. So you have done it. Next what you have to do? First step is over. Use. So obviously till now you have learnt. After writing a user defined data type you are using it. You wrote a class, you wrote a subclass. After writing these two data types you went on to use it. How did you go on to use it? Simple usage, what we are saying is, we used to declare a variable like this. Yes or no? A is equal to simple. See, I have shown you how to design a class. I had shown you how to design a subclass. After designing them, what were you trying to do? Use it. How are you trying to use? First, you are declaring a variable of that type. Yes or no? So A is equal to null. Yes. So here you are declaring a variable. A reference variable again. It's a declaring what? 1 second. A is equal to null. So you are declaring a reference variable. So Java is very clear. For any reference variable, the value what you give is null. Declaring a reference variable of abstract class data type. You should be very clear with it. Abstract class data type. You are declaring a variable of type what? A, no? A is a variable of type what? Class A. But what is class A? Abstract class data type now. So that's why fully see the statement. You are declaring a reference variable of abstract class data type A, capital A. A is a variable of type it. You are doing box B means what? You are declaring a reference variable of class type. Box weight BW. You are declaring a reference variable of subclass data type. Now what is this? It's a reference variable of abstract class type. Perfectly valid this is. So I am trying to use it now. I am trying to use the subclass data type. Understood now? Deriving is over. Next what I have to do? Use it. So I am trying to use. I declared a variable. Because say, before you use the data type, you have to declare it first. First define it. Then declare it. Then you have to use it. So defining over declaring. This is declaring. That is defining. Understood? See, generally int. They are already defined. We use it directly. Int is defined by whom? Language people. We declare and use it now. Int A. So So that is built in, but these are user defined. So you defined now and you declared, now you have to use. So how do you use user defined data type in Java? By creating objects. Primitives you will use directly, but for which one? User defined data types you have to create objects. So let's try to create an object of this abstract class. Okay, so I will say new A. Same thing you have to use to create objects. We use the keyword called as new only, or new is an operator given by Java language to create what? Objects. So after creating the object, then you'll store the reference of that object into a variable. Perfect. Same thing here also. How you work with the class, how you work with the subclass, how you work with abstract class, how you work with the class and subclass, same thing we are trying to do with what now? Abstract class. Nothing new. How you work with the class, how you work with the subclass, same way we are trying to work with abstract class. But this will give you error. Understood? Why it gives you error? You can never ever create an object of abstract class. You can never create it. You can never create an object of an abstract class. See, I am teaching you how to use an abstract class now. Deriving is over. So how to use an abstract class now. So you are trying to create an object. See now, you cannot create an object. Only if the object is created, memory is allocated, then the reference value of that memory can be stored in the variable. So here right hand side only is not executing. You know, when you use the assignment operator, there are two conditions. What is that? Left hand side and right hand side. If there is value on the right hand side, then it will give it to the variable on left hand side now. So when memory only is not allocated or object only is not created, where is the question of giving reference value to reference variable? We cannot give the address now. So ruled out. So object only has not got created. Now the question is, why can't you create an object of abstract class? That's the next question. Okay, you cannot create an object of an abstract class because it's an unclear class. It's an unclear class. Supposingly, see, if I'll tell you example. Supposingly if an object gets created, if it had got created, the code would have come into existence like this. Okay, and A would have referred. Fine. A.M1 something will execute. A.M2 it will execute. But what will A.M3 execute? It cannot execute anything. M3 is unclear because you have not written any logic there. So even if the object is created, there is no use of this object because it's not containing complete code. If it is containing complete code, then something meaningful. Now it is not containing complete code. What is the use of this creating an object of this class? See, creating an object means bringing code into existence, nothing else. Creating object means bringing code into existence. Only if your code is clear, then you bring it into existence. When it is unclear, what is the use of bringing it into existence? So you can that is the reason you can never create an object of abstract class. See, remember the rule. Unclear things cannot be brought into existence. That's simple in which one? Simple English. Unclear things cannot be brought into existence is in simple English. Technically, if you say bringing into existence is called as what? Creating object. Technically, if you see. So if anything is unclear in Java, you cannot create an object. Or if anything is abstract in Java, you cannot create an object. Technically, if you see. Normal English, anything which is unclear cannot be brought into existence. Technically, anything which is abstract, you cannot create an object. Both are same only, no? One I am telling normal, one I am telling technically. So anything unclear cannot be brought into existence. When you don't know what it is, how will you bring it into existence? Cannot be brought into existence. Technically, how do you say? Abstract things cannot be, means abstract class cannot be, you cannot create an object of abstract class. You cannot create object of abstract class. Why? Because it is unclear. So means you cannot bring it into existence. This is wrong now. Understood? Okay. Shall I clear this now? Now what to do? Next question. So the only way you can bring it into existence is by making it as clear. Give the body for it. Then you bring it into existence. That's it. Now how will you give the body? You have to do the implementation now. You do it. Sorry, I have written M2 here. Change this to M3. That's it. M1 is there, M2 is there, M3. Okay, M3 is abstract method. So fine then. Next. So there are two methods concrete, one is abstract. You make this method as concrete. Definitely you can create the object. So Java sees to that you can only bring clear things into existence. clear things into existence. So how do you make this clear now? Question is that you have to give the body now. Where will I give the body? Can I go remove this brace, change it like this? No. You are not supposed to modify anybody's class. If I have written this class, you are not supposed to touch my class. So what you have to do? You cannot touch my class. So you have to give the body now. You have to give the body. So one option is write all the old, means you have to write a completely new class now. Class B, or just I'll write it here. Class Z. Okay. So you want to give the body for it. So one option is write void M1. Write the same logic. Then again write void M2. Then again write the same logic. Then you write void M3. Now give the body. Here you write whatever logic you want. Inside Z M3. Means give the body. That's your wish. But you are again redundantly writing the logic for M1 and M2 now. Why are you wasting time and energy? So do not write this code. Understood? But what was your intention? Your intention was not write those two methods. Your intention was to give the body for the third method. So to give the body for third method, you decided not to modify here. You cannot modify. Okay. So then again, that's the reason you try to write a new class. Instead of doing this, it's better you inherit which functionality? M1 and M2 functionality, and just add the logic for M3. Finish now. So we go on to write what now? Class B extends A. So which data type I am using now? Subclass data type. Why do you use a subclass data type? You are clear with this now. For adding or changing implementation. Subclass is always used for adding or changing implementations. So class B extends A. So I will write void M3. So I am changing the implementation of M3. Yes or no? What is it? It's an abstract method. I am making it as concrete method. I am changing now. So I can write any logic here. SOP inside BM3. Now which is the better option? Z class is better or B class is better? Result is same. But writing a Z class is an headache because you have to write the old logic, then write the new logic. Two methods, simple method like that, okay. But what if your class is having 20 concrete methods, big methods, and one abstract method? Can Z have 20 concrete methods again? And then one extra method? Better is what? You write a subclass. Why do you write subclasses? You know now, rule. Subclasses are written for inheriting the functionality of one class into another class and adding or changing functionality. That is why I am choosing subclass now. Understood? We are using what here? Subclass. So this is how you use a subvision now. Abstract class. So one, you write a subclass. Then to use it, what you have to do is write how to use abstract class now. Writing is over. To use now, first rule is what? Write subclass which has implementation of what? The abstract method. You have to write it. So to use this abstract class, this is the first rule. To use, writing it is over. Now I am showing you how to use it. So once you write it, next what will I do? Z I will clear now. Z is waste class. Don't write Z. Instead write what? B. Okay. And extend it. So let's remove Z now. It's not required. So now B is a concrete class. Why is B concrete class? M1, M2, M3. M1 and M2 it's inheriting from superclass. But they are concrete. M3 is concrete. You might argue, no, B is having one abstract method in superclass. Yes or no? Yes, it's having abstract method in superclass. But the same method has been overridden in what? Subclass. And you know criteria for overriding is what? Object. So if you create B object and call M3, this method is never executed. Which method gets executed? Subclass 1. Finished. So there are no abstract methods in class B now. It looks like you are having it, but there is no abstract method in class B because you are overriding it. Understood? So once B is a concrete class, what you can do? You can create an object of B class but not A class. But B is a subclass data type, A is a abstract class data type. Understand the difference? Understood? So here, see this, I can do this now. B, what are you doing? Declaring a reference variable of subclass data type. Subclass data type B. Fine. BB is equal to null you add. BB, that is, okay, BB is equal to null. For any reference variable, we provide the value as null only. Let it be class, let it be subclass, let it be abstract class. So once it is declared, see, new B, yes, valid code. Why? concrete class. Now B object is created, no doubt about it. What are the members of B now? M1, M2, all are concrete. So this is concrete. M3 is abstract in class A, but in subclass M3 is concrete. So this is address is 150. B object has been created. But to work with the object, you need a reference to the object, no? Always to work with complexity, what do you need? You need a handle. So in Java says what? Reference variable is the key to the complexity. Reference variable is the key to the complexity, or reference variable has the ability to refer to your object, or reference variable holds the reference to the object, anything. So I will hold it in B, valid. Right now I am holding it in object and variable are of same type. Your object what you have created and variable are of same type. Next, I can call the methods b.m1. Yes. Where it will search? Same rule. Subclass. What members you can access depends on the type of variable. Which member gets access depends on the type of object. Same rule. No change. b.m1. It will search in subclass. Doesn't find. Executes from superclass. b.m2. Searches in subclass. Doesn't find. Executes from superclass. b.m3. Finds in subclass. Executes from subclass itself. Perfect. Now this is how you use which one? The subclass now here. Are you clear? But fine. You can also say A is equal to B. This is also valid. Why? A is a superclass of type B. So superclass variable can refer to subclass object. You know the rule now. So here what's happening? Superclass variable, superclass reference variable can refer to subclass object. Yes, correct. But what members can be accessed from the object depends on the type of variable. Same rule. Which member gets access depends on the type of object. Same rule continues. So A.M1 also valid. A.M2 also valid. A.M3 also valid. A also can refer to this, and all the methods can be accessed. So finally, if you want to use an abstract class, what you do is, see this. You are having an abstract class. Write it. Write the subclass first. Then what you do? Second. Say A is equal to new B. This is how you write. Finally, the formula is coming out now. What is the formula? A is equal to new B. And this formula is true under two conditions. One is what? If class A is a superclass, then class B should what? Subclass. Then if class A is an abstract class, then class B should be what? Subclass implementing the abstract method. This is the rule. Are you clear with this now? Be clear with this point. Till now we have seen superclass and subclass, but now we are saying same rule, but A is an abstract class, but B is a subclass implementing the methods of abstract class. Clear this? So we'll see. I'll type and show you this now. Program. Yeah. This is one very basic, simple example of abstract class. In this basic example only, many things are there. Understood? In this basic example only, many points are there. We'll start seeing it now. So how to derive abstract class? You understood? Deriving. Next, how to use? How to use this abstract class? Write on subclass. Then create an object of subclass. Then use the reference variable of type abstract class. Now your abstract class can refer to B object and it can work with B object. But you can never create an object of abstract class. It is impossible to create an object of abstract class. Why? Because it's an unclear class. As simple as that. Clear? Unclear things cannot be brought into existence. And there is no use of bringing unclear things into existence also. Should I clear everything? Should I clear all this? So I'll write abstract class demo. Can create one folder by name abstract class. Sorry, one second. Let me rename it. I didn't give the proper name. Give 32. Save it. Now let's see. Class A. So void M1. Yeah, see there's a class A now. You know how to work with the class A? It's very simple. A is equal to new A. Fine. A dot M1. You know how to work with the normal class. That is very simple for you. So everything works here perfectly. Small a. So everything works here perfectly. So this is a valid code. You know about this. There's nothing new about this. So both of them are, these are what? These are both concrete methods. M2 is also what? Concrete methods. Why it's a concrete method? Because it has a body or it has implementation. It is having logic. That's why it's called as concrete method. Now let's try to add one abstract method here. See, this is called as an abstract method. Method which does not have a body is called as, sorry, M3 I'll change. Okay, method which does not have a body is called as abstract method. Let's try to compile. So it says missing method body or declare it as abstract. So means the body is missing. Either add the body or make the method as abstract. So what will I decide? I don't want to give the body. So I'll say abstract class void M3. So done. Now let us compile again. It says A is not abstract. Class A is not abstract now. First it will tell method is not abstract. Then it will tell. So it forces. The compiler forces you. Okay. If your class is having any abstract method, it forces you to make the class as what? Abstract. It forces you. Okay. So this is how it forces you, and you have to make your class as abstract. Means very simple. Your normal class cannot have what? Abstract methods. Only abstract classes can have abstract method. You know the members of the class now. What are the members of the class? Variables, methods, constructor, all that you know. I've written members of the class. In methods you can have what? Concrete methods. But the class cannot contain what? Abstract method. So the only data type which can contain an abstract method is abstract class. So abstract class is the only data type which can contain what? Abstract methods. Okay. So yes, it is containing now. Okay, so now this is I changed because class cannot hold the abstract method. I made my data type as abstract class. So this is perfect now. So what will I do now? Let's see this. One more thing. I'll just change this. A is equal to null. Understood? So here what are you doing? Declaring a reference variable of type of abstract class type. So you can declare a reference variable of abstract class type, no doubt about it. But, okay, you see this, 1 second. You can declare it, see it compiles. And for abstract class also what is happening? Just notice, dot class is generated. Understood? This is Java file. In your Java file you are having two classes. So that's why two dot class files have been generated. What are the two classes? This is one class. This is another class. So even for abstract class what is generated? Dot class. So your abstract class when you write it is saved in .java file. It's a data type, but we save it as .java. But finally when it is compiled, dot class is generated. Fine. Anyway, dot class is generated. Now see this. It compiles. But let me try to create an object now. Here is where we get an error. Okay. A is equal to new A is error. See this. It is abstract. it cannot be instantiated. Means the JVM says if any class is declared as abstract, see the class has to be loaded into the JVM now. You know now, if an object has to be created, first phase is what? Class getting loaded into the JVM. So class has to get loaded. Class will get loaded. Now JVM says the class has been declared as abstract. It will load here. After loading, what it is trying to do? Trying to create an object, but you are telling, you yourself are told what? It's an abstract class. So if the JVM says any class has been declared as abstract, it will not create an object of it. If the JVM says any class has been declared as abstract, it will not create an object of that class now. Till now it was creating objects because none of your classes were abstract. They didn't have that keyword. Understood? So see this, carefully observe this keyword where and all you can use this abstract keyword at only two locations. Only two locations you can use. One is at the class level, other one is at the method level. Do not try to use the keyword wherever you want. Understood? You cannot use abstract keyword with variables. You can use this abstract keyword with only methods and class. Means if your method is abstract, make the class as abstract class. Are you clear with this? Okay. So that's how it's done. Now next. So fine. What will I do now? So that's why I'll write class B now. Class B. One option is write a new class and write all the story plus new code, old code plus give the body for M3. But instead of that, I'll extend void M3. Inside A, M3. Understood? Inside, sorry, B, any logic you write, that's your wish. B, M3, fine. So now, I cannot create new A, definitely I know that. But definitely I can create object of what? B. What am I doing? Is equal to null. Declaring a reference variable of subclass data type. Correct? Huh? So then after that, see I can declare, plus I can create an object of P class also, there is no doubt about it, because it's a concrete class. So and that address I'll hold it in subclass variable. Subclass variable can refer to subclass object. Perfect. But I didn't call any method, so I'll call it now b.m1, b.m2, and I can call b.m3. So see M1, M2, M3. So one more thing what you are observing now is abstract methods can be overridden. Abstract methods, static methods cannot be overridden, but abstract methods can be overridden, and they support, very crucial point, they support dynamic polymorphism. Abstract methods support dynamic polymorphism. Means, see here, A is equal to B. Understood? A dot M1. Correct now? A is equal to B. A dot M2, A dot M3. A dot M3, which method it will execute? From subclass now. I am commenting everything about B now. See this. So I can call the methods either from A object or with A variable or with B variable. This is dynamic polymorphism now. M3 is executed from superclass or subclass? Subclass. So abstract methods support dynamic polymorphism. And you can see M3 is getting executed from subclass, but I am invoking it with A object. Understood? So abstract methods support overriding, and they support what methods are supporting overriding? They are supporting dynamic polymorphism. Are you clear? This is a very crucial point, and you will see the advantage. I am only showing you the dynamic polymorphism here. What is the advantage of this? Next I will show. Understood? What is the advantage of this? Next we will start seeing. Are you clear with all this? Yes. Next you understood how to write it, how to do it and all. So now how many dot class are generated? 3. Because B is also there now. A dot class, B dot class, and your demo dot class. 3 dot classes are there. Fine. Next. One more thing, what generally people do are, see, I'll write something like this. Now is this a concrete method? What is this then? Error, huh? What will happen now? So, till now also, you are very weak in members of the class. This is actually a block. This is an instance block. So, do not get confused. Sometimes you will write concrete methods. Generally, it means why I am showing you this is, you will write concrete methods. By mistake you will put semicolon here. That time it will be treated as what? Block. Understood? So be careful when you write the programs. Now see when it gets executed. I mean abstract class can have blocks. That I'll teach you next. That topic is there, I'll teach you. But just I'm trying to show you, make you understand the syntax. After semicolon also, if you give the body, it is not treated as concrete method. Semicolon is used as what? Termination, no? So this is a block. And it gets executed during the creation of object. I have not written constructor and all. When I write constructor and all, you will understand that. Hello gets executed when? See, I am not calling any method now, but still hello will get executed. Still hello will get executed. I am not calling only. Because it's a block. We will see the execution of that later. But it's treated as a block. When the object of B is getting created, the instance block gets executed. I'll add constructors and show you. Constructor, static block, all that I'll add and show you. But understand, this is not a concrete method. Don't think concrete method is there and you are given the body. Clear? Fine. So are you clear with all this now? Clear this? So we'll see some more examples on abstract class. This is the first example. So the next thing what we'll see is, okay, I'll show it off here itself. See, till now we are having an abstract class. Which one? Abstract class A was there. You are having void M1, which was a concrete method, void M2, which was a concrete method, but void M3, which was a abstract method. Yes? Yes or no? This is how it was. So I'll write class B. Understood? Class B. Understood? Extends A. Why am I writing class B extends A? It's a subclass. What are the reasons you write a subclass for? Adding or changing logic. Yes or no? So yes, you extended A and you modified the logic of M3 by making it as concrete. Understood? Now the rule of subclass continues. It's not that you have to only extend and override M3. Mandatorily you have to override. Rule is there. You have to override M3. But apart from that, you can write your extra method. That is optional. Understood? Don't think a class which is extending an abstract class should override only what? Generally you have doubts. A class which has extends an abstract class has to override only what? Abstract method. No rule like that. If you want, that is optional. You can write M4 method also. This is valid. This is optional. And you know why you write a subclass now? For adding or changing logic. So M3 you are changing logic. But that's also nothing but what? Adding a new logic one. So M4 is what? Adding logic. Means, but this is a completely new logic. So you are writing M4. If I want, I can overload M1 also. That is also possible. All this you can do. Int Z. So in the class which is extending an abstract class, you can do anything. That is up to you. But mandatory is you have to override what? Yeah, this is overriding is mandatory. Okay, this overriding is mandatory. Apart from that, do whatever you want. You write extra variables, methods, overload, do anything. You can override M2 also. Are you following now? Are you getting this concept? When your class B is extending a compulsory, you have to override M3. Apart from that, what you can do? Override M1 also. You can override M2 also. That's your wish. But compulsory, you have to override M3. Okay. And if I want, I can write extra method also. One more extra method I am writing. Which method? M1. Valid. But this is overloaded. Your wish. Anything you can do. Anything you can do. Are you clear? But don't think only one method you have to write. You can write any number of members. Because it's, remember, it is a subclass data type. Simple as that. What all rules you learn for subclass data type is applicable to class B. You learn the rules of subclass now. Same, it's a subclass. Just see it as a subclass. Nothing else. And subclasses are used for adding or changing implementations. So just I'll add one extra method and show you. Okay. But if you add an extra method, you cannot invoke it with what? Superclass variable to subclass object. What members you can access? Depends on the type of variable. Let's see that. Subtract void M3. I'll remove the block now. Block I'll remove time being. I'll explain that later to you. Should I clear what I have written? So see this, the extra method what we'll add is now It's not mandatory, but if required, do it. If I'm not telling it's mandatory. Mandatory is what? Overriding M3 is mandatory. Other things is optional. And it is supported. Why it is supported? Because it is a subclass. Inside B, M4. Are you clear? So if I create B object, now, yes, very interesting. With B, I can access all the members now. What all I can access? B dot M4 also I can call. Yes or no? With B I can call all the 4 methods, M1, M2, M3, M4. You want me to override any other method, M1, M2? Okay, first we'll complete this. All the methods are getting executed. But the same if I refer with A is equal to B, what happens now? Huh? I cannot access M4. But M3 is called from where? Subclass. You know the rule. M3 is called from subclass only now. Okay, but if I try to call M4, A dot M4, it gives you compilation error itself. So what members you can access from the object depends on the type of variable. Once you can access it, which one gets access depends on the type of object. So here what has happened is B object has got created. Be careful with this. What are the members of B? M1, M2, M3 is an abstract method, M3 is overridden method, M4 is the abstract method. So B, correct or no? M3 is abstract method, M1, M2, M3 in superclass. These are the members of class A. These are the members of class B. I created object of B. With B I can access all. B dot M1 searches in subclass. Same rule. Doesn't find executes from superclass. M2 searches in subclass. Doesn't find executes from superclass. M3 searches, executes. M4 searches, executes from where? Subclass. M3 and M4 from subclass. M1 and M2 from superclass. But the address I can give it to what? A. But with A I can call only 3 members. But which one gets access depends on the type of object. I have overridden M3, it will execute from subclass. If I override M1, M1 also is executed from where? Subclass only. Do not forget the rule. Understood? Rule of overriding is becoming more intense now. Understood? And this is what will lead into very high level of abstraction. See this. I am overriding M1 now. If you are interested, you do it, man. Compulsory you have to override which one? This one. Okay. So I am overriding and I will say inside B M1 now. So for clarity purpose, I will write something like plus 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 plus. Just see which one gets executed. A dot M4 is error now. Understood? But M3 is executed from where? Sorry, M2. Sorry, M1, no, M1. M1 is executed from B, subclass, B class. I am calling it from what? A dot M1. You call it either A dot M1 or you call which one? B dot M1. From wherever you call. Here also I am calling. Here also I am calling. See, M1 and M3 you notice. M1 and M3. I am calling M1 twice. And M3 also I am calling once. Okay. But both are supporting what? Dynamic polymorphism. Instance method also supports dynamic polymorphism. Abstract method also support dynamic polymorphism because both support overriding. Instance methods and abstract methods both support overriding. And what can be overridden? Support dynamic polymorphism. Are you clear? So now if you see the formula of what? I'll comment everything. It's not work. Now see the rule of dynamic polymorphism. Here you'll understand. If you want to understand dynamic polymorphism, A is equal to nu B is the best way. Now which method executes? You'll understand. A dot M1. Can I access? Yes. A dot M2. Can I access? Yes. A dot M3. Can I access? Yes. A dot M4, can I access? Yes. Then you are telling yes, sir. Railway track, huh? Yes. So A dot M4, so it will give me error, compilation error, because you cannot access M4. So I will comment M4. But when M1 and M3 are both executed from subclass BM1, BM3. M2 is executed from superclass. Are you clear? Clear example of what? Dynamic polymorphism. Okay. Now all this is okay. Now by chance, next thing. One more thing now. Okay. See, now when class B is extending A, I told you what is the rule, mandatory rule? It should override. Yes or no? Okay. I'll adding extra method. Okay. I'll not override. I'll remove M1 now. So M1 has been removed. Okay. And class B is extending A. It is writing on extra method. But it is supposed to override what? M3, no? So class B is mandatory, it should override what? M3. By chance, if it doesn't override, see what happens. B is not abstract. Means make the B class as abstract. Now it is having what? Abstract member. B is also unclear class because it is inheriting unclear things from superclass. It is inheriting unclear things from superclass. So B is not abstract and does not override. Means either override the abstract method or make the B class as abstract class. This is possible. So it's mandatory that you have to override what? Or make it as abstract like this. This also, B is also unclear class. Understood now? So subclass has to compulsory give the body for what? The abstract method. Other things it can do. Overriding other methods, adding extra methods, overloading, anything it can do. But compulsory it has to give the body for the abstract method of superclass. Are you clear with this? Otherwise this class also should be declared as what? Abstract class or unclear class. Why it is unclear class now? Because it is inheriting the abstract features. And obviously B becomes unclear class. Are you clear with all this? Okay. Shall I move to the next example now? Plenty of examples we are seeing now. Okay, next. More things we'll see. See now, class A is there. It is having void M1 concrete method inside A M1, but it will have two abstract methods. So obviously when you compile you will get error. So you have to write abstract, yes. And if your methods are abstract, class also has to be declared as abstract, yes. Fine. So your class is having one concrete method now. Sorry, one concrete method but two abstract methods. You can write as means I'm just increasing now. You can write any number of abstract methods. There is no rule that you have to write only one. Understood? In your abstract class, there is no rule that you should write only one abstract method. So some more examples now. Understood? Otherwise you think I have to write only one abstract method. Nothing like that. You can write any number. So now when class B extends A, what should it do? It should override two methods. Understood? Extra it can have. I'm not stopping. Class B can have extra members, but compulsory it has to override what? Abstract both the methods. Which one? Void M2 and M3. SOP inside B M2, void M3, SOP inside B M3. Valid. Extra is optional. I'm not telling you add it, but I'm just adding it to make you understand a subclass can have extra member. Are you clear with this? You can type this and see by yourself. Yeah? So now which object can I create? A or B? A or B? Both? So you can never create an object of abstract class. See, directly if you want you can say BB is equal to new B and call what? B dot, see which object is created now? M1. M1 is concrete. M2 abstract. M3 abstract. M1 is concrete. Now see M2, concrete. M3, concrete. Fun, concrete. So with B, I can call all concrete members. Which are M1, M2, M3 and fun, the extra method. Understood? Or you can say A is equal to null, A is equal to B, but with B I can call A with I can call what? M1, M2, M3, but I cannot call fun. Understood? See, M2 and M3 are supporting overriding and they are supporting dynamic polymorphism. Clear? So A can refer to this and it can access only superclass members. Clear? Any questions? Okay, but by chance if I say A is equal to new B, by chance, okay, by chance if I say A is equal to new B, what happens now? See, just I am using the same object. A is equal to new B means what? A will refer to this object, but I can access only what? M1, M2, M3, fun I can't access. Yes or no? See here what I did, I created the object and gave that reference to A. Means I created object of B, held the reference in B variable, the value of B I gave to A. But here what I am doing? Directly I am saying A is equal to new B, valid. But now my question to you is, now from this object, means this, forget all this code now, this is a program, another program now. I want to access the subclass member, what should I do? Yes, you can typecast, valid. You can typecast what? A to B, means you can cast reference variables, valid. Now why are you casting? Same old reason. Only one reason, to access subclass members, no other reason. And with B I can access what? B dot M1, P dot M2, B dot M3, P dot fun. Clear this? This is very important now. Which one? We can typecast abstract class to subclass type. Typecasting is possible. Why do you do that? To access subclass members. This becomes very important all. And dynamic polymorphism still. When you typecast A to B, B is referring to this. Which object gets executed? See here, you understood the syntax now. A has been casted to B and given to B variable. Fine. B dot M1 superclass means find, looks in subclass, doesn't find, executes from superclass. B dot M2 executes from subclass. B dot M3 subclass. Same. You know how it works? But only extra thing what I can access is fun. Any questions here? Any questions here? It's very crucial. I'll show you this. Typecasting of what? Abstract class to subclass type. But I need this example, I'll read. Shall I clear this part right side? Abstract class demo, what method is abstract? Okay. Many abstract methods demo. Many abstract method demo means my class will have what? I'll just modify here itself. Class A is their concrete method. M2 will make what? Abstract. I'll delete off class B first. One second, I'm copied and pasted. I have to modify all the code. Many abstract method demo. Okay. So my class is there, and see again, I have to make this also as abstract. So now my class A is having how many abstract methods? 2 abstract methods. It will compile, it will generate a dot class, no doubt about that. But now class B decides to extend it. So you decide to give what? Body for M2. You have to give the body. Okay, now I am trying to compile. See there, I have not done the implementation for what? M3. I am giving body for what? Only one method, M2. Now compile, it says give the body for M3 also, or make which one? B as abstract. So I decide to give body now. Are you clear? So now B is a concrete class. Extra method you want, you write, that's optional. Void fun. Inside B, fun. That is optional, you can write. Now I can create BB is equal to new B and work. BB is equal to new B and work. There is no problem with this. And I can call all the methods. B dot M1, B dot M2, B dot M3, B dot fun. All methods will get executed. There is no doubt about it. M1, M2, M3 and fun. But by chance, if I write A is equal to new B, what happens? A dot M1, I can call this A dot M2, I can call this A dot M3, I can call this, but A dot fun is error. Yes or no? So but I want to access the fun member, my requirement. I want to work with subclass member. So what should I do? Typecast. See, I am typecasting now, carefully see. B is typecasted to A is typecasted to B now. And if you want to print the address, I show you the address also. B dot, first I will access and show you B dot M1, B dot M2, B dot M3, B dot fun. See, typecasting is becoming very essential now. But rule is simple. Fun is getting executed. See here, M1, M2, M3. Last fun is getting executed now. Yes. If you want to print the address and see. I'll show you both of them are referring to the same object. This is value of B. See, this is value of A. Here I'll print value of B. Rest all will comment. Or if you want, let it be address, you can understand what is there. Both of them are referring to the same object. See, value of A and value of B are what? Same address. So you can typecast. Clear this? Why do you do typecasting? To work with subclass members. Are you clear? Okay, fine. Some more things we'll see now. Yeah, sometimes you'll have abstract class. Yes, like this. It'll have two abstract methods. Now what will happen? See, another example. More examples we are seeing on abstract class. That's it. So what will happen? Class B decides to extend A, but it doesn't want to do full implementation. You understood the requirement of B? It wants the logic of M1. Now see how it is, inheritance is happening now. We are going to inheritance now. Class B is inheriting A. It wants the logic of M1. It will inherit. It wants to give the logic for M2. It will give. Understood? It wants to add an extra method. Yes, that will also happen. It can write on extra method, void fun. This is another example. But it is not interested to give a body for M3 method. This will happen. So what happens now? This becomes again partial implementation now. This is nothing but what? Partial implementation, because you are not giving complete implementation. So you are not doing complete implementation. Means you, because why it's not called a complete implementation, you are not giving the body for M3. You are not giving the body for M3. So that's why it becomes incomplete implementation. Again compile, you got the error just now. I showed you. It's mandatory you have to give the body for both the abstract methods. But if you don't give it, now you can make the class as abstract. Now you cannot create object of A also. You cannot create object of B also. Both are abstract classes. Because when the class is loaded into the JVM sees this class is abstract. As soon as it sees the class is abstract, it will not create an object of it. It will not create an object of it means what? It will not bring the code into existence. So what to do now? Yes, you will create one more class. Agreed. Yes? You will write class C. But what will class C do now? Huh? Why extend B? It can extend A also, no? Yeah, this is where you have to take decision now. Multi-level or hierarchical. I thought you all inheritance, no? Why did I teach you? To blindly extend A, B, C, D. I know you are very good in English. After A comes B, after B comes C. Doesn't mean that C will extend B, B will extend A. Understood? So I am not teaching you A, B, C, D now. Yes or no? What am I teaching you? Inheritance. Understood? So, see, you have the option here. B is an incomplete class which is extending A. So here there are two abstract methods, one concrete method. Here there is one concrete method, extra method, fun. M2 is there. So B is having actually three methods. Which method? M1, M2, fun. B is having actually three methods, M1, M2, fun. But A is having only one concrete method. So it's having M1 because it's inherited from superclass. Plus it is having M2. Plus it's having fun. Okay, M3 is not overridden. So now class C, when it extends, now it should decide what to inherit. It can inherit A class also, it can inherit B class also. What is the benefit of inheriting A? What is the benefit of inheriting B? It will inherit all the features. Plus it has to override only M3. It has to override only M3. Extra method it can add. I'm not telling no. It can add an extra method. That's optional. But when it extends B, it will get all the features. But sometimes scenario will be class C does not require these two logic. It requires only the logic of what? M1 of A. So that time class C will extend A. That becomes hierarchical. So whether to do multi-level or whether to do hierarchical, you have to be very clear about this now. Simply because you can inherit, don't go on inheriting blindly. What will happen now? Man will start barking now. If man extends dog, what will happen? He'll start barking. So that's why what you have to do? Extend animal. You know that hierarchy, no? Because you can inherit and get all the features, don't inherit everything. First of all, you are very intelligent. Understood? So that's why don't inherit. Then wrong things will come into you. Clear? So that's why, so you have to decide either like this or like this. But right now I'm showing you multi-level. We'll come to hierarchical later. Hierarchical we'll see later. Okay, but my intention is what? I want the logic of M1 in A, M2 in B and fun of B. That is my intention. That's why class C is extending B. For that reason I'm extending B. Understood? Else you could have done what? Class C extends A now. Understood? Yes. By chance if class C extends B, now it becomes mandatory for C to what? Override M3. Compulsory it has to override. Else again this class also will become what? Abstract now. It goes on. So this is C. Again clearly C. This is partial implementation. What did I use? Abstract class data type. This is partial data implementation. What data type did I use? Abstract class. So wherever there is partial implementation, we go on to use what? Abstract class, abstract class. But here I am using subclass. This is not class. This is what? Subclass. And you know why you use subclass? To add or change implementation. So what are the data types you are using here now? Abstract class, subclass. I am not at all using class here. Class is used for a different purpose, which I will be telling you later. Clear? So here class C extends B. Compulsory you have to give the body for what? M3. Mandatory, otherwise this also becomes abstract. Inside C, M3. Plus extra method is optional. I will write on extra method like test. This is optional. I am not telling mandatory because it's a subclass. The subclass has the ability to add what? Extra members. It has the ability. If you want, you add it. Else leave it. It depends now. Understood? Now, among the three classes, which object I can create? C. I cannot create an object of A also. I cannot create an object of B also. Definitely I can create an object of C. So see this, C is equal to new C is highly valid code. An object of C gets created. What are the members of C now? M1, concrete method of A. M2, abstract method of A. M3, abstract method of A. Then M2, concrete method of B. Fun, concrete method of B. Understood? Then M3, concrete method of C. Then test. These are the members. These are the members. Sorry, referred by C object, no? C variable. Now with C I can call all members, man. And how it executes, you know very well. C dot M1, can I access? Yes. So how does it check? See, compiler checks what are the members you can access. All it will allow, compiles. But during runtime, test is checked in subclass, executes from subclass. Sorry, first M1, no? M1 will be checked. So M1 is checked in subclass, doesn't find, executes from, tries here, doesn't find, executes from superclass. You know how it executes from method? Same rule. That's why I was stressing so much on execution of methods there, so that here it becomes easy for you. So methods are always searched in the bottom, not found, executes from superclass, executes from, if not found, executes from superclass. C dot M2, again searches in the bottom, doesn't find, executes from superclass. There are two M2, but preference is given to B class. Because it's an object of C, first C preference, next B preference, next A preference. C dot M3, it executes from subclass. C dot test, fun, doesn't find, you know now how the execution happens, fine, but I can access all the members. See, B is equal to null, A is equal to null, you know the story now. I can refer A is equal to C also, yes, or I can say B is equal to C also, both are correct. But with A, I can access only 3 members. See, these two are errors and these are all correct. Error you will get for these two. So superclass variable can refer to subclass object. What members you can access from the object depends on the type of variable. Which one gets executed depends on the type of object. A.M1, can I access? Yes, compiler will compile. But where will M1 be seen? Here, not found. Executes from where? Tries to execute from here, not found. Finally M1 is executed from here. M2, from where it executes? Checks here, not found. M2 is executed from here. M3, checks in the bottom, doesn't find. It executes from, M3 is executed here itself. Understood? Got it now? See with B now, B dot M1, B dot M2, B dot M3, B dot fun, B dot test. But with B you can access one extra. Fun is extra. This is becoming error. Yes or no? So with C all members, with A only 3 members, with B 4 members. C 5 members, A 3 members, B 4 members. This is how you can access. So what members you can access from the object depends on the type of variable. Are you clear this? Can you program this?
We have to declare M3 method in class.
Not required. His question is, should I have to declare M3 method in class B? Not required. It is inheriting anyway. Understood? If required, you can write it. Generally in college they teach you like that. So see, class B is extending here. It is giving the body for M2. But you are not giving the body for M3 means, what should you do? Make the method as abstract. And if the method is abstract, class B also becomes abstract. So writing this is optional. If you want, you write. Else, leave it. Writing this is optional. Because anyway class C will extend means you will get it from superclass now. That is optional. But in colleges you have learned like that. This is, writing this is optional. Yeah, any questions? You can type this now. Understood? You can work with this example now. This you type and see. Okay. The last thing I'll teach you. Another example it is. It is another example, but I'll modify it here itself. Okay. The modification is here. Now, I'll remove class C. Understood? It's a new example. Shall I clear this? Shall I clear this example? Okay. The example is what you know. The next example. Class A is there. It's having one concrete method, 2 abstract methods. Fine. It is having 2 abstract methods. Now, 1 concrete, 2 abstract. Class B is interested in M1 method. So that's why it will inherit and tries to override what? M2. M2 it is overriding. Extra method it wants optional. If it wants it will add, else it will leave. That's secondary. Let us remove it only. Okay, class B has decided to inherit M1, but it has added M2 logic. but it doesn't want to give the body for M3. But it wants to use M1 also and M2 also. It doesn't want the logic of M3. Understood now? But if it doesn't implement, what is the problem? You'll get error, compilation error. Just now you saw. You understood the requirement. Class B is interested in inheriting M1. It is interested to give the body for M2. But it is not interested with M3 at all. It is not interested with M3 at all. But if he doesn't write M3, he'll get error. What error? Make the class as abstract. Now if the class is abstract, he cannot call M1 also, he cannot call M2 also. Because he cannot create an object. Only when he creates an object, he can call M1 and M2. But problem is he cannot create the object now because he is not giving the body for it. So that is when sometimes when you are not interested, to give the body for methods, you can simply give blank braces like this. And this is called as deceiving the compiler. Now you compile, compiler will compile it. Because it sees you are giving the body, no. There is no logic here. But you are giving the body. So definitely compiler will compile. So what happens now? B dot class is generated. It's a concrete class. There is no logic here. Understood? Otherwise you write 1000 lines of code, simply time pass and comment everything. Your option. Understood? It's your wish. Don't write any logic here, or write fully happily whatever you want, then comment it off. The idea is what? It's having one body now. That's it. Understood? So now see, this is there's body, but there's no logic, no implementation. There's body, but there is no implementation. But B is a concrete class. That you understand now. B is a concrete class because the M3 method is having body now. M3 method is having body. I can definitely create an object of B, no doubt about it. And that time I can say what? BB is equal to new B. B dot M1 also will execute. B dot M2 also will execute. M3 nothing it will execute. There is no logic, but it will not give you error. Error it will not give. It's a member and it is not going to give you any error. This is very important. So they'll ask you in interview, what do you mean by deceiving the compiler? Okay. So what do you mean by deceiving the compiler? I'll explain it to you just in a while. See this. But first you see the output. BB is equal to new B. Object of B is created. What are the members? M1, M2 abstract from superclass, M3 abstract from superclass, M2 and M3 concrete implementation. Yes or no? So this is B object. I can call all the methods. B dot M1, B dot M2, B dot M3. Happily it will compile and execute also. But M3, nothing it will execute. Clear this? Okay, I'll explain what is deceiving the compiler on system itself now. Clear? And when will you do deceiving compiler? When you are not interested to give the body for abstract method. Deceiving the compiler is nothing but that only. Okay, when you are not interested to give the body for abstract method, that time what you do? You just give the body for the methods and deceive the compiler. Deceiving the compiler means what? You are cheating the compiler. Compiler will get cheated and it will get compiled. But cheat is a unprofessional word. Yes or no? Unprofessional word we should not use because we are software engineers. So we say deceive. That's it. See this. In the same example we'll see. See M2 is there. I'll remove all this. Fun I'll remove. Okay, M2 I have given the board. Which one? See this is the same example. Abstract class A. Now you try to compile. You can comment rest all. No, you don't bother about all these things now. So many things are there. Just I'm reusing the same example. If you want, you can try it another example. See this now, abstract class A, M1, only M2 we are giving the body. I'll compile. So it says B is not abstract and does not override. So what will I do now? Compiler is not allowing me to compile. Understood? So I'll go past the compiler now. Going past the compiler means how will I go? See, I'll write like this, void M3A. Now I'm deceived it, over. Now it will compile now. This is only called as deceiving the compiler. Understood? So generally when you do not want to give the body for abstract methods, sometimes we deceive the compiler by giving body or braces. That's it. This is only called as deceiving the compiler. Compiler will compile now. Now I can create the object. BB is equal to what? New B, and I can call what? All the methods. See, it will compile. It will execute also. M1, M2. Which one? Okay, M1, M2 it prints. M3 it is not executing because there is no body for it. Sorry, body is there, no logic inside it. Or as I told you, if you are interested, write whatever logic here. Write whatever you want to write, and then finally you do what? Comment it. So instead of wasting time in writing all silly logic, I leave it as blank itself. This also is correct. Write logic, don't write ABCD. Understood? Are you clear this? Yes. So this is what is deceiving. Deceiving the compiler is nothing but when you do not want to give the body for an abstract method, just give empty braces. Clear? Now finally, last I'll teach you some members in abstract class. What members I'll teach? I'll add on constructor. I'll add some blocks. Which block? Static and instance block. And then we'll complete the class. Understood? Just I'll add some members. So it's till now I worked only on abstract methods, but abstract class can contain other members also. So the first member which tomorrow I'll go with variables. Today I'll go with only constructor and block. Simple flow you see now. See, before I go to members, one more concept I'll show you. Just see this. One more concept. Void M1, M2. If you are good in Java, you'll tell me this answer. This is a very, very, very important trick question. In fact, you don't know how important this is. System.out.println means, see, there are two concrete methods. Yes or no? Can a class have both concrete methods? Means all concrete methods, all are concrete here, full concrete it is. Understood? But still be declared as abstract. Are you following my question? Can a class have all concrete methods? So generally how do you work now? A is equal to new. Before I show you the members, just I am showing you one more example. A dot M1, A dot M2. Correct? Huh? Both it is executing. Okay, just see this. Can a class have all concrete methods and still be declared as abstract? Yes or no? There is not even a single abstract method there.
Not possible. Yes, sir.
It is possible. It is possible. See, it will compile. So it's not, see, it is not mandatory that the class should have, abstract class should have abstract method. It's not mandatory that an abstract class should have abstract method. Should have, it's not mandatory. But if it is having if there is an abstract method, then you should make the class as abstract. If there is abstract method, then you make the class as abstract. But if all concrete methods are there, it's optional. Okay, but the problem now is you cannot create an object. Notice. Understood? You cannot create an object of which one now? Hey, this is wrong now. But how do you A is equal to, sorry, 1 second. New A is error. The JVM sees, as soon as it loads the dot class into the JVM, it sees the class is abstract. It sees the class is abstract. And not create the object. But it's a concrete class. Now what to do now? So best is what you do now, If you want, see, I want to, but see, it's an abstract class, but I want to execute both the methods which are concrete. Both are concrete methods. So one option is I write class B extends A. Is one option. And what? What logic I'll write here? Override. So what you'll tell? Void M1. No, many people think like this. Override and call what? Super dot M1. No. Not needed. Super dot M1. See, this is one way. Void M2. I show you. This is one way you can do it. Super dot. This is actually we don't do like this, but I'm just showing you. Okay, class B extends A. So what I'll do? I cannot create an object of A, but definitely I can create an object of which one? B, no? I can create what? Definitely I can create an object of, forget this, A. I cannot create this. But definitely I can create an object of B. B is equal to new B. And I can call B dot M1. B dot M2. Yes, correct. But instead of that, see, it will execute. But how it executes? M1 in subclass executes. This will invoke that. But don't do that. Simply write an empty class. It's as good as the same thing. See the same output. What do you want to write? Don't override. If you don't override, which method gets executed? See, class A is there. M1, M2 is there. This is M1 method. This is M1 method. When you created the B object, so what are the members? M1 from class A, M2 from this one. There are no members in class B. Fine. So B members, B what it will do? Checks the member in subclass, doesn't find it, execute from superclass only. Why do you want to override and then invoke? Not required. But this is possible. What is the concept now? Can a class have all concrete methods and still be declared as abstract? Yes. Okay. And if you make it as abstract, the object doesn't get created. So if you see like this, it will be confusing. Better way is, see, I'll put the question like this. I do not want to create an object of a class. What should I do? Declare the class as abstract or have a private constructor. Both two options are there. So sometimes you'll prefer private constructor concept. Sometimes you'll prefer abstract class concept. Which one when? We'll see later. But these are the two ways you can stop the instantiation of a class. One option is definite interview question. What are the different ways you can stop the instance of a creation of an instance of a class? One is by making constructor as private. Other option is by making class as abstract. But don't think, means in one situation we'll do one thing. In one situation we make the constructor as private. In one situation we make the class as abstract. I'll show you the examples that. When in what scenario you do that, I'll show you the examples. Are you clear? Definite interview question. And one more thing here, dynamic polymorphism also works. You don't have to create an object of B. See here, what will I do? Still, this will work. A is equal to new B. Still it works. A dot M1. What members I can access depends on what? Variable. Which one gets access depends on the object. Perfect. Clear? Clear this? So because it's nothing is there in subclass, it executes from superclass. This is also nothing but what? Deceiving the compiler. You are writing class B, B dot class is generated. Understood? Sometimes class will be concrete. Understood? And they'll be declared as abstract. You cannot create an object now. Now that time what you do? Write a subclass which extends it. Don't write any logic here. Don't write any logic here. Simply create object of B class. It will inherit all the members. You call now. It will work. Are you clear? Clear this? Yes. Now we'll go to the next topic. Which one? Members. Members will go. Are you clear? Okay. See now. Yeah, M1, M2 if you want to have concrete. See, I'm just continuing now. So what will I do? I'll have one constructor. So can abstract class have constructor? Highly valid. It can have, no doubt about it. Inside a constructor. Can abstract class have Static block, yes, inside a static block. Highly valid. Can abstract class have instance block? Yes, highly valid. So I'll leave all this and I'll make M1 as static. I'll make M1 just to access the method. Okay, just I'll show you. So abstract class can have what? Static methods also. Okay, so now let's see. I'll call a.m1 method, see what happens. I'll remove everything here. Okay. I'm just calling now. I cannot create an object, but definitely I will do what? a.m1 method. Understood? Now see what happens. Static block gets executed. Class got loaded now. So static class can have static block, but instance block and constructor did not execute. Why? Object has to be created, but I can't create an object of what? A. But see when they get executed, a is equal to new a. So see this, object you cannot create, but static block gets executed if I call the static member. Fine, leave this. Now I'll just show you the execution. See when the constructors are invoked now. See B, just see this. I'll have one B constructor now. Inside I'll write all the members here, same members here. Same rules of inheritance follows, man, nothing else. Static inside, B static. Inside, B instance. Inside, B constructor. Now I'll create an object of B. Check this out. B is equal to new B. Now what happens? B object I can create now. A static, B static. A instance, A constructor. B instance, B constructor. Look at the flow. Tomorrow I'll use constructors extensively. That time you'll get the clear idea. But this is the flow. I created B object. Okay, so when B object is created, same flow. First A class is loaded, so A static. Then B class is loaded, B static. Then what happens? Super, same story. Default super is added where? Because you are not calling the super class constructor, it will be added. Then what happens? It will invoke default constructor. Understood? So then instance block executes A constructor. Then instance block executes B constructor. Understood? Just I am showing you, it was executing till now fine. But if I have a parameter in my superclass constructor, now it will not execute. Yes or no? Because default super is added here. And default super looks for what? Default constructor. Cannot find symbol constructor A. So all this we'll see tomorrow. So all your rules of how much you put effort in learning subclass will help you here again. Understood? So if I remove it, it works. If I remove it, it works, or add a constructor, default constructor you write now. Because here default super is added. Okay, so tomorrow I'll show you the invocation of constructors and all that. Static block, instance block and all that. Clear this? But by chance, see this. First I'll call a.m1. Now what happens? Static block is executed here only. Here only B static. You know that now? Because A class is already loaded. See A static a.m1. Then B static B instance. Sorry, B static A instance, A constructor, B instance, B constructor. So go through this flow. It's very essential now. Tomorrow we'll discuss about blocks, constructors and more things. Okay, if you have any questions here, ask. Clear? So an abstract class can have what? Concrete methods, abstract method. Static method also it can have. I showed you just now. It can have static method, concrete method, abstract method. It can have constructors. It can have blocks. Static block and instance block. Only one I have to add. What? Variable. Tomorrow I'll show you. Again, what variables you can add? Static and instance variables. All you can add. Clear this? Okay, that's it.